Hidden among the stars are some of the strangest and most magnificent objects in nature, objects known to us in detail only during the last 100 years. We live in a house of stars that we call a galaxy. Our efforts to judge the appearance and size of this galaxy of ours have been rather severely handicapped by the fact that we are always inside of it. We can't get out of it. It's just as though we were eternally locked up in a small room inside of a house, a normal dwelling place, and asked to describe the appearance of that house. We can't do it, but we can look out of the windows of our little room, just as we can look out of our galaxy and see other houses around us and see other galaxies in space around us. And because of a rather general resemblance of these galaxies, most of them at least, to each other, we feel that we're pretty safe in assuming that our galaxy looks like the rest of it. From that and from other bits of knowledge, we find that our galaxy is a great disk of stars and dust and gas, shaped very much like a vast wheel. It is big. The diameter of our galaxy is at least 100,000 light years from side to side. Now, a light year is not a measure of time. It's a measure of distance. It is the distance that light travels in a year at the rate of 186,000 miles every second, so that you can see that this galaxy of ours is big. We also think that it is rather flat, disc-shaped, with a thickening in the center, a thickening which may extend perhaps as much as 10 or 15,000 light years. In this galaxy, there are stars and dust and gas. The star population we estimate to be at least 200 billion stars, and our sun is just one of these stars. Now, from our position in this galaxy, a position which we shall discuss a little bit later on, we can see on any one night from any one place on the Earth about 4,000 of these more than 200 billion stars. And we also can see through telescopes other things than stars up there. Clouds, bright glowing clouds of gas, clouds of strange dark material, and of course the stars. And all of these things belong to our galaxy. They are in this great house of stars in which we live. Now, the stars themselves, we find, have a frequent tendency to congregate, to get together. In fact, if we were to take as a sampling of these stars, the 20 brightest stars that we can see from the Earth, and each one of these stars looks to us from our eyes only as a single point of light, we find that out of these 20 stars, 7 are actually double stars. There are 2 stars up there contributing to the light that we see, and an 8th is a more complicated system, a system of 3 stars. Now, 8 out of 20 is about 40%, and we believe that this percentage of duplication holds pretty true in the region of the galaxy that we can see. About 40% of the stars are doubles or better, which puts our sun, you see, on the side of a very small majority in being a single star. In other regions of the galaxy, which we cannot see and do not know as well, the percentage may be even greater. Now, as typical of some of these duplicated stars, let's take as first a simple double star. There is a beautiful double star in the constellation of Cygnus, the Swan, a summer constellation. This star is Albireo, and it is one of the loveliest things we can see in a small telescope. It doesn't take very much of a telescope to show this as a double star. One of the 2 stars up there is a brilliant, deep, rich royal blue, and the other is pure gold. It's a wonderful sight to see. A little more complicated system of stars is found in a constellation not too far from Cygnus, again in the small summer constellation of Lyra. One of the stars up there is, to our eye, a single star. If we put a small telescope on it, that single star breaks down into 2 rather widely separated stars. And then if we increase the power of this telescope, each of these 2 in turn breaks down into 2 more stars. So we have 4 stars, all in the same system, moving about each other. This is the famous double-double in Lyra. Its astronomical designation is Epsilon Lyrae. In the winter constellation of Gemini, one of the 2 very bright stars which give that constellation its name, Gemini means the twins, is a very complicated structure indeed. Now, we see this star, Castor, as a single point of light. A telescope, no matter how powerful, will only bring us 3 stars. But the spectroscope, with its betraying system of dark lines, tells us that 2 of the 3 stars we can see with a telescope are in themselves double. And this is a diagram of the Castor system. We have the central star going around a tiny orbit, probably impelled by the gravitational influences of the other stars around it. The second star is double, and its 2 components are going around each other, and the whole business is circling around the central star. So with the third member of the system, 2 components going around each other, and the whole business circling around the center. This is the very complicated Castor system. Now these 3, the simple double, the double-double, and the more complicated Castor system, are typical of the hundreds of thousands of double stars that we know exist in our galaxy. And the stars congregate even more thickly, for we have what we call clusters. Now, there are galactic clusters. They're called galactic clusters because they belong to our galaxy, and all the stars in them partake of the general motion of all the stars in the galaxy. This vast wheel is turning, you see. And the first type of galactic cluster is the open cluster, or the coarse cluster. They're called that because the stars in them seem to be fairly widely separated. Now, one of the best known of these open clusters is in the constellation of Taurus, a winter constellation. And here you can see it. Now, the little grouping of stars high up in the right-hand corner of your screen is the famous cluster of the Pleiades. Now, the Pleiades we can see quite easily as 6 fairly bright stars. Actually, a small telescope will show you about 60 stars. But a photograph such as you see here indicates that there are about 300 stars that belong to this cluster. The Pleiades is about 350 light years away from it, and the stars that compose it are all big, bright, hot blue stars. Now, in the same cluster, in the same constellation, rather, of Taurus, there is another cluster, even more open, the Hyades, which looked in the picture you saw a minute ago like that letter V lying on its side. The Hyades doesn't have as many stars in as does the Pleiades, but it looks bigger and more widely separated to us because the stars are nearer, about half as far away as the Pleiades. And again, in the late fall and winter sky, we find another cluster, which seems to give us an indication that even the clusters themselves cluster. This is the famous double cluster in the constellation of Perseus. 2 clusters of stars, so close together that they can be brought into view at one time in the field of a small telescope. These coarse clusters are typical of 300-odd that we know of in our region of space. Now, all the stars in a single cluster seem to have a common motion in space. They're all moving together in the same direction. They are the same kind of star. An analysis of their light tells us that. And they probably had a common origin. Now, in addition to these coarse clusters, to these open clusters, there is another type of star grouping which is even stranger and more fascinating, and that is the globular cluster. These look like tremendous, closely packed spheres of stars. We know of about 90-odd of these, which are within our view. And like the coarse clusters, a great many more of them are probably hidden from us by the dust and gas and countless other stars which are in the Milky Way. This particular cluster that we are looking at now is in the constellation of Hercules. Again, a great, rather dim grouping of summer stars. And you'll find it in this picture in that line of stars which seems to slant from near the center of the picture up toward the upper right-hand corner. These clusters, those that we know of, range in distance from us from about 18,000 light years for the very nearest to about 10 times that distance for the most distant ones. The great cluster in Hercules is about 35,000 light years away. It has a diameter of about 30 light years. And of course, it looks almost impossible to count the number of stars in it. Estimates of the stellar population of this cluster range from about 50,000 stars up to about 100,000. And these are all tremendously big red and yellow stars. They have to be big and bright to cast their light to us from this tremendous distance. And our sun, if it were up where the Hercules cluster is, would never even register its presence on a photographic plate. It isn't that much of a star. Now, these globular clusters and their distribution have played a large part in our estimate of the shape and size of this star house of ours, the galaxy in which we live. Dr. Harlow Shapley, a number of years ago, made a very careful survey and an examination of these clusters, the 90-odd that we could see. And he found that more than half of them seemed to be concentrated in one region of the sky, in our summer southern skies near the constellations of Sagittarius and Scorpius, which we believed held the hub of our galaxy, of this wheel of stars in which we live. Now, that concentration there indicated that something was off-center, either the galaxy or that we were. And it is far easier for us to be off-center than for the galaxy. So Shapley figured that our position was not anywhere near the center of the galaxy where it had been supposed to be for a number of years, but near one edge of it, about a third of the way in from the one edge toward the center in one of the arm structures of our galaxy. And that these globular clusters were placed around the edge, either top or bottom or sides of our galaxy, so that we could see them there, standing somewhat like great sentinels. Now, this has been confirmed to a large extent by our ability in recent years to photograph stars in other galaxies outside of our own and other great houses of stars. Some of the nearer and brighter ones we are able to resolve into stars. Here is the edge, for example, of one of the biggest and brightest of these galaxies. This is the great galaxy in Andromeda. And we can see in this picture the globular clusters spaced around the edge of this wheel of stars, which confirms Dr. Shapley's theory and which really confirms our conception of the size and shape of our galaxy. You can see there the importance of this evidence that we are getting from the stars. Now, those we can see from our galaxy, from our position in it, rather, inside of it, we can look out, of course, the sides of it and see relatively few stars. If we look toward the center of it or toward the edge of it, we see a tremendous condensation of the stars. That makes that lane of light that we see in our summer and winter skies and call the Milky Way, because that is our view of the edge of this galaxy from our position inside of it, as though we were looking up along one of the spokes of the wheel. Now, here is a picture of a small portion of the southern Milky Way, and we can see how the stars concentrate as we move from the top toward the center and from the bottom toward the center, and here is the Milky Way. Here is the light from those billions of stars concentrated in this region of the sky. To show you a better example of this star concentration, let's take a look now at one of the great star clouds in the constellation of Sagittarius, toward which we believe the hub of our galaxy lies. Look at this picture. Here are stars, just stars, so closely packed apparently, so lined up as we see them that there is hardly room for another one there. Just millions upon millions of stars lying in that direction in space. These are the stars, their clustering, their concentration, their various distributions. Now, up among the stars, there are other things. We spoke of them before. The first explorers of the sky, with their fairly crude telescopes, saw up there, in addition to the stars, little faint, wispy patches of light. Looked like little bits of fog, and they called them little fogs. The word for that is nebula, and these are the nebulae. There are thousands of these clouds of bright gas up there. Bright because they are excited into brilliance by the radiation of stars which are in the clouds or which lie fairly close to them. This light that we see when we look at a bright nebula is partly reflected light from dust and other things up there, and it is partly light which is absorbed by the gases of the cloud and re-emitted. They're excited, you see, and they give out this light. Now, there is one bright nebula which we can see as a rather vague star without a telescope, one of the very few that are visible to us. And this nebula is in the great winter constellation of Orion. Here is an outline of the stars in Orion. You can recognize the famous belt of three stars that crosses it from the upper right to the lower left. And from the left-hand star of the belt hangs another little arrangement of stars, which is spoken of as Orion's sword. Well, the center object in the Orion sword, which looks like, as I said, a little vague star to us, is not a star at all. It is the great nebula in Orion, a magnificent cloud of gases, a very tenuous cloud. It's big. It measures about 6 light years in diameter. Through a very small telescope, it looks something like the flame, a green blowtorch flame. And it is only in a long-period photograph like this one that we can see the tremendous and wonderful detail in that cloud. This is about 600 light years away from it. And it is one of the finest of the bright nebulae that we know. There are others, of course. Here is one that is in the constellation, again, of Sagittarius, where so many stellar wonders are concentrated. This is the Trifid Nebula, called because it seems to have 3 distinct divisions. And in our summer skies, we can, again, in the great constellation of Cygnus the Swan, we find another very interesting cloud. This one is another bright nebula, excited into brilliance by a great star in Cygnus, which lies fairly close to it. And I wonder if you can see anything vaguely familiar about the shape of this bright cloud. This is the North America Nebula. And with a little imagination, you can probably picture this as Florida with the Gulf, with the Caribbean Sea and Mexico and Central America. This is a very interesting example of the tricks that the clouds of dust and gas in space can play upon us. Now, there is another group of bright nebulae which almost fall into a class by themselves because they have a similarity of shape which is not possessed by those that we have just been talking about. These are called the planetary nebulae. They were christened, again, by William Herschel, who first began to study them, and they are called planetary not because they have anything to do with planets, but because they look like little planets when they're seen through a telescope. They show a disk. They are mostly circular in cross-section. And here is a typical planetary nebula. This is the Dumbbell Nebula in the constellation of Ursa Major, the Great Bear. It is a spherical cloud of gas, and it is about the same diameter as our whole solar system, about 7 billion light years. And like so many of these planetary nebula, it has a very hot, bright star at its center. Now, we don't know why these things occur this way. It may be that the gases have been emitted from the star over a period of years by unusual activity. The star may be absorbing them. The star's radiation is certainly making them visible. But there are a number of planetary nebulae very similar in shape to this one. They all seem to have that central star. Now, another one of them, up in our summer skies again, in that same constellation of Lyra, for example, where we saw the famous double-double, is the Ring Nebula in Lyra. Here we have that same cloud, circular in cross-section, the same hot, bright star at the center. But this one looks like a luminous donut. Now, actually, it isn't. What we're looking at is a semi-transparent sphere, a globe, if you will, of gases. And it looks more dense to us around the edges because here we are looking through a great deal more gas than when we look directly down through the center. Now, there are a couple more of these planetaries which are most unusual and famous in their own rights. One of them is found in the constellation of Taurus again, and this is the Crab Nebula. It was first seen by a famous Irish astronomer, Lord Rosse, who called upon his imagination somewhat vividly, I think, to christen it the Crab Nebula. But this is a strange affair. It is a cloud of dust and gas and debris. Now, one theory as to the origin of many of these planetary nebulae is that they are the ruins, if you will, of a star which blew itself up. Now, in the old days, such things did happen occasionally. There suddenly appeared in the sky a very bright star where there was evidently no star seen before. And because they were new to these people, they called them new stars, and we use the Latin word nova for these stars. This cloud may be the result of such a star. It is expanding. In the 100-odd years man has been observing it, its rate of expansion has been very carefully measured and is about 600 miles a second. Now, if we figure back at that same rate of expansion, we can find out just about what time the whole thing started to spread out, and it was about 900 years ago. Now, if such a cloud came from the explosion of a great star, that star should have been bright enough at that time to make some record upon history. The Western astronomical annals don't show any such star. But in the Japanese and Chinese annals, there is a record of a very bright star. They called it a guest star. It appeared suddenly, stayed for a little while, and disappeared again. And that was in the year 1054. And just about in this same place, we can see the Crab Nebula. There is still another very interesting nebula, which is also in that same constellation of Cygnus where we found the North American Nebula. This is in the lower region of Cygnus, and we see this beautiful, delicate, lacy cloud of bright gases made to glow again by the radiation of stars near them. Now, this is just a portion of a much larger region in the sky. And if we look at that larger region, we can see perhaps the result of an accident that happened billions of years ago. Taking the whole field in which this particular nebula lies, we see that there are several clouds of gas whose general outline may be considered to form a great circle. Perhaps this, like the Crab Nebula, is the ruins of a star that blew itself to bits billions of years ago. We don't know, but that seems feasible. Now, in examining the skies, astronomers of some 100 years ago were puzzled by the fact that there were places where there didn't seem to be any stars up there in the sky. William Herschel, again, whose study of the skies was very intense, called these things holes in the sky. Now, we know that isn't possible. There are no places in the sky in which there are no stars. There are stars, they may be more, there may be fewer, but there are always stars. We know now that these places that Herschel called holes in the sky are actually clouds of dust obscuring the light of stars beyond them. Here again is our region of the Milky Way. This is the region which lies about the Southern Cross. Here is the Southern Cross, these four stars. And just below that is one of these so-called holes in the sky. This is the coal sack. It was seen hundreds of years ago and is visible and apparent as a dark spot without a telescope. And it is impossible that the stars of the Milky Way should come up so thickly clustered to the edge of it, then stop and resume as it went beyond. There is gas and dust obscuring in this place the light of the stars beyond. Now, let's go back again to our North American Nebula for a moment. And here we can see this North American Nebula. And just to the right of it in the picture is another nebula called the Pelican Nebula, seeming to be two separate and distinct clouds. Actually, we believe that this is one continuous cloud, overlaid, masked by this dust, this dense cosmic dust, which gives it the shape that looks so strange up there in the sky. One of the most famous such clouds of dust that we can find is again in that treasure house of astronomical wonders, the constellation of Orion. This is the Horsehead Nebula, again discovered by Lord Rosse and named by him, and perhaps looking to a vivid imagination, something like the arch, neck, and head of a horse looking out of a stall. But look at this picture. Look at the right side of it and see how bright it is and how many stars there are visible on that side of the picture. Now look at the left side and see how few the stars are. And see the edge of this great cloud cutting across the picture from top to bottom, just about in the middle. We are looking at a vast cloud of cosmic dust. Now this dust is everywhere. We find it scattered through our galaxy. We can find it in other galaxies whose pictures we can take from ours, looking out the windows of this house. Here is one of them edge on, and we can see like a streak around the edge of that galaxy, the dust. Here is another picture of another galaxy, taken this time so that we can see it almost in plane from top to or bottom, depending on your point of view. This definitely shows the arm structure of galaxies. And the dark streakings in there are not open places in the stars, but they are obscuring dust and up there. Now, this is cosmic dust. This is a very important part of our universe. We believe that this dust is the building blocks of the universe, the stuff out of which everything is made. And out of the almost universal presence of such dust has come a very interesting theory of the formation of stars themselves. Now here, of course, are few of these grains of dust, tremendously large. Actually, we believe that these dust grains are microscopic, maybe 200,000 to the inch. But they are out there in space, and they are near stars, and they are receiving the radiation, the energy, the light, and everything else from these stars, so that half of each grain of dust would be lighted by a star near to it. The other half would be dark and would cast a cone of shadow out in the direction away from the star. Now, there are so many of these. They're so thickly crowded, as you saw in some of the pictures we've showed you, that it must be that at times one of these will be right behind the other. Frequently happens. Now, that means that this star is receiving all the radiation. It's being pushed in that direction by that force, the radiant force of the stars, so that this one, for example, would be pushed into this one. The two of them would clump together. Now, that starts something. These two then have a greater mass, more gravitation than the rest, and they begin immediately to draw other grains to them. The clump builds and builds and builds until it becomes tremendous, and gravity pulls the particles together. Pressure inside the thing increases, and with pressure comes an increase in temperature. And when that temperature rises to the millions of degrees necessary to trigger the atomic processes that give light to the stars, we have another star. That is what happens. Now, there is evidence of this clumping which we can see. And we know that in our galaxy and in most of the average galaxies, there is a great deal of dust. We believe that 10% at least of the mass of any galaxy is dust and gas. The rest is stars. And in our galaxy, as in probably a typical galaxy, this 10% of dust is not evenly distributed. Most of it lies in the outer regions, in the disk and in the arms of the galaxy. And about 50% of the arm structure of the galaxy is dust and gas. That is where this process may happen, which we believe may be producing new stars. Now, you remember the Trifid Nebula that we saw a little while ago. If we look closely at that, we can find in 2 or 3 places. Here is one. A very small, looks small to us, but remember this is a long way away, a very tiny clumping together of dark. And these dark regions are dust and gas. This may be a star being born. We don't know. Our whole lifetime, in fact, man's whole history, is so infinitesimal compared to the vast expanse of time in astronomy that we shall probably never be able to see a star come into being. But we may be witnessing it here. Now, let's sum up. We've had the stars. We've had their clustering. And we have seen the importance of these clusters of stars to us in determining some of the facts that we believe to be true about our galaxy. We've had these bright but beautiful clouds which are lovely to see. And we have this all-important cosmic dust, the stuff of which everything is made. These are the things which we find in this house of ours, lying inside of our galaxy.